Hey, today I want to show you how you can learn to rationalize an algebraic expression. This means that how you can get rid of a radical when you need to somehow, just move it away of your expression. So I've got a paper right here and with some limits problems that we're going to solve. But first of all, let me just show you how you can rationalize something. So let's suppose we have, I'm going to choose, this problem. So let's say we have the square root of x plus 7 minus 4 divided by, let's say just simply what? X. Now, if we have this, how do we rationalize this? When we say we want to rationalize something, what we're going to do is we're going to multiply the numerator, the conjugate of the numerator of our expression, in the top and in the bottom of the expression that we have, okay? So now, two rules that we need to take into account. I'm gonna write them down here so you remember. First of all, you're gonna see why this is very important. If you have the square root of x times the square root of x, this is equal to, well, remember, the square root of x squared. And these two, well, they will go out. And this is just simply equal to this is just simply equal to x, okay? No square root. That is our first rule that we need to know. And our second rule is also the following. The conjugate of an expression, which is what we are going to multiply by, let's say we have a plus b, the conjugate of this expression is equal to a minus b. So we're just simply going to switch the signs. This is the conjugate for this expression, or the other way around too. So now in this case, how do we do it? Well, remember that you're going to multiply the conjugate of the numerator, top and bottom. Okay, so that means that what you're going to do is you're going to graph, I'm going to graph another marker. And now what you're going to do is, you have the square root of x plus 7 plus 4. Let me close the square root here. Plus 4, remember we're switching the signs, over the same thing, the conjugate of the numerator in our previous expression. Plus 4. If you see, we're not changing anything in the initial expression, because this is just simply multiplying by 1. So now we can continue to simplify this, so you see how this radical goes away. So what we would have in this case is we can FOIL these two expressions that we have. And now the first two terms, well, it would be a multiplication by this and this. And that is the same scenario that we have down here. Eventually, the two radicals, since they would go to a exponent of 2, they would cancel out. So we get something like square root of x plus 7 squared plus 4. Oh no, in this case, no, never mind. Just this is our first term, yeah. So we would get this initially. Now let's keep FOILing. Now we would have plus 4 times square root of that same expression. So x plus 7. And now minus 4. Minus 4, the same expression, x plus 7. Now I'm gonna write it down here. Minus 4 times 4, that's just minus 16. And all of this divided by this expression in here. Now I'm just gonna keep it like this. I'm not gonna distribute. So we would get x times square root of x plus 7. This is supposed to be a 7. Plus 4. So this is what we get. Now let's keep simplifying. So we would get that. Remember, the square and the radical, they go away. And you would get that this is equal to x plus 7, because they go away. X plus 7. Now these two expressions, they will cancel out, so you get nothing. And now you have minus 16. Minus 16. And all of this is over. Now I'm going to distribute so you see it more, in a more compact way. So we would get x times the square root of x plus 7 plus 4x. So this would be our final expression. Well, now actually we could simplify these two, and 7 minus 16 just as minus 9. And we could get minus 9, and that would be all. Now, of course, you could keep simplifying things, but if you see our main goal, which was to get rid of this expression up here, it is gone now, okay? We have no radical in the numerator right now. We just move it to another place. And that is what we wanted to do with rationalizing. So I hope you guys understood this. So before we get into the limits problems in our following video, let's do some more problems about rationalizing. So let's say we have the expression 3 over square root of 2. Now in this case, we're not rationalizing the numerator, but rather the denominator. It is the same idea or the same logic, but now in this case, we're doing it because we cannot divide by a irrational number, like the square root of 2. So what we can do is pretty simple. So think about it. If you multiply this by itself once again, well, you're going to be able to get rid of the radical, okay? So that would be simply square root of 2 over square root of 2 multiplying this expression. And this would just simply, this would get you 3 times square root of 2 over, now this is square root of 2 squared, right? And this is just simply, well, they go out, and you get square root of 2 over 2. And that is your expression, okay? That's how you should rationalize something like that. An expression like this. Now, what about if we have a binomial in the denominator? Let's just simply put a number right there. So, I'm going to give you another example about that. So, let's suppose we have 4x over square root of 2 again plus 3x. Now, once again, we cannot divide by the square root of 2. So we need to take it out of the denominator. So how do we do that? Well, once again, in this case, we cannot multiply by 2 by the square root of 2, because if you see it, well, in this case, you would get out, this multiplied by this, distributing, you would get once again 2, but in this case, you get 3 times x times the square root of 2 in the denominator. And that is still a radical down there. And we can use that. So what do we do? Well, once again, from the previous explanation, well, we take the conjugate of this expression and we multiply it. It's the same idea. So we would do is just simply square root of 2 minus 3x, remember we switch the signs, over square root of 2 minus 3x. This is virtually the same thing as if we were multiplying by 1, which means we're not doing anything to the expression. But now if we distribute our binomials in this down here, so what we would get is these two, they go out because they're square root squared, and that's just simply the base, the base that we have. So we're gonna have 2. Down there we're gonna have 2. This times this one goes minus 3x square root of 2 plus a 3x square root of 2 square root of 2, and now this would be minus 9x squared, minus 9x squared. And now all of this is dividing, we can distribute, yeah, let's distribute, why not? We would get 4x square root of 2 minus 12x squared. Minus 12x squared. This is the same as if we had the same on the top, square root of 2 minus 12x squared over. Now these two terms, they go out, they're opposite signs, and now we get 2 minus 9x squared. And now you see, we went from this, having the radical on the bottom, to now having a radical on top, okay, in the numerator. And that's how, well, what you can do in order to get rid of a radical as a denominator, or just simply rationalizing the denominator.